Welcome to the video where we are going to understand something new called Databricks Declarative Pipelines, which has recently been jailed in June 2025. The evolution of delta tables into smarter unified lakehouse orchestration engine. In the world of modern data engineering, one reality has always stood out. Pipelines are the backbones of every data system. They move clean, transform, and transform terabytes of raw data into insights. But we build those pipelines has been evolving. But how we build those pipelines has been evolving. So initially we used to have, I remember Unix scripts we used to have for orchestration, and we would write the ETL in PySpark uh, or that type of code we used to write, and then we used to use Unix script for orchestration. So this was the basic thing we used to do. But then later, when the Databricks came into picture, we started using the chain notebooks and jobs. Like we used to write the things in notebooks, and we used to chain them together and then execute those notebooks. So that type of projects also we worked. Recently, we started using DLTs in some of the live data or streaming data. We used to go for something called Delta Live Table. That would be um, that would be an amazing feature of Databricks where everything was built in house, already built out of the box, and we just used to set few properties, and that pipeline would be completely set up. Databricks declarative framework for managing the data pipeline was DLT earlier. So we just used to declare few things and it used to work. But now we enter era called declarative pipelines 2.0. So if we call DLTs as, let's imagine that we call it as declarative pipeline 1.0. So this declarative pipeline 2.0 is a new era, a major evolution that transforms DLT's philosophy into a general purpose, most importantly open source, declarative orchestration framework for all pipelines, both batch and streaming, SQL, Python, Databricks managed, and open source Spark. So these are all the properties of declarative pipelines. Let's explore how this system works and what problem it solves, how it can be used in practice. So first of all, it is there for both streaming as well as batch source. For both of them, it is allowed. Declarative pipelines can be prepared. The most important thing about being declarative is like you just can declare few sequels and the pipeline would be automatically created. So for example, let's say if you have a streaming source where files, tables, or streaming data coming from IoT or and data feeds is coming into at single place, you can have a stream processing where you would have append and CDC, both the flows that you can define, and then you can have a target like sync, or it can be even a streaming target. Then on the similar lines, you can have a batch as well. So as I said, streaming and batch both are allowed in declarative pipelines. How declarative pipelines has evolved over time. From DLT to declarative pipelines, how things have changed. So when DLT launched, it revolutionized how engineers build ETL pipeline. Even DLT itself was a game changer. You could declare tables dependencies instead of scripting the job sequences. DLT automatically used to handle the incremental logic, retries, and data quality checks. We just used to write logic in SQL or Python, and Databricks used to manage the orchestration and everything. But DLT was somewhat narrow in scope, limited to specific ETL workflows inside Databricks. Databricks realized that declarative philosophy could go further, and therefore they introduced something called Declarative 2.0, an open source specification runtime engine can contribute to Apache Spark that powers Databricks' new Lakeflow declarative pipeline feature. Now, what is the major difference between DLT and declarative pipeline? That would help you a lot. So let's say in terms of scope, the DLT would have ETL pipelines, batch and streaming, whereas declarative can have any pipeline. Declarative pipeline can be of any type, and it can be ETL, ML preparation, ingestion, orchestration, any type of declarative pipeline is possible. API, if in terms of API, proprietary to Databricks. But the most important thing that has happened with declarative pipelines is declarative pipelines have been open sourced, open specifications, Spark declarative pipelines. So we have realized that uh, the product, if goes open source, is being developed in a better way. We have seen that happening with Spark, MLflow, and therefore they open source the declarative pipelines as well. Then the feature is execution, managed completely by Databricks, whereas in declarative pipeline works in open source Spark and Lakeflow managed. Language SQL Python limited is there. Now here SQL Python is again limited for coding, and YAML and cross languages are also possible. Orchestration, in terms of orchestration, it is within the single pipeline, but whereas unified with Lakeflow jobs for multitask tasks. In terms of governance, basic DLT lineage is there. In terms of governance, Unity Catalog integrated lineage is available. And then deployment is workspace only. Within workspace you can deploy the things, but in case of declarative pipeline it can be through GitOps CI/CD version, because it's completely based out of YAML, right? It's a YAML controlled. You can define YAML and automatically a declarative pipeline would be created. It is that sophisticated, and therefore the deployments are possible to be integrated with like different tools, right? From GitOps, CI/CD, any CI/CD tool you can very easily integrate because it's a YAML. Resource management, DLT has its own clusters, whereas declarative pipeline is serverless or auto-scaled in Lakeflow. In essence, Declarative 2.0 is evolution and generalization of DLT, turning that was once an internal Databricks ETL framework into something called Universal Declarative Orchestration Layer. Let's understand the architecture. At its heart, declarative pipeline defines what transformation exists in terms of SQL or Python, their dependencies, and how data evolve. The system then takes care of how and when those transformations execute. The core concepts that are there in case of declarative pipeline is table or view. So first core concept is pipeline. It's a logical flow of dataset defined declaratively. And then comes the table, materialized dataset produced by the transformation. Streaming table, table that continuously get updated from the streaming source. Incremental table, table that processes only change data since last run. Dependencies, automatically inferred from references, example from live sensor, from live silver orders. Then expectations, so their data quality rules are there that are already present, or similar to DLT you would have a lot of data quality rules here. Even I'll show you 2 minutes in demo. You can have the answers or the information or the outcome of that expectation in a one table. Automatic orchestration, engine handles scheduling, backfills, retries, checkpoint. Observability, automatic orchestration, engine handles scheduling, backfills, retries, and checkpoints. In terms of observability, it has a built-in lineage, run history, and metrics. So let us see how we have built a pipeline here. There is a beautiful online editor that Databricks has provided where you can completely build this pipeline. Let's click on the edit pipeline, and I would show you how the pipeline can be simply defined. So earlier, when there was a need for building a pipeline, let's say you are building it on AWS, you have to define at least, I would say, 100 things, because you have to create roles, then you have to give access, then you have to integrate the S3 location, you have to give permissions for them and whatnot. And after doing all these things, to put configurations and stuff, it's too complicated. So compared to that, writing an ETL pipeline on Databricks is that simple. So how and what you do is, you simply, let's say, create a what you do is you simply go to jobs and pipelines, and then let's click on this, and then you can simply say create. You can click on create and create ETL pipeline, the second option. The moment you create ETL pipeline, you would get an amazing online editor like this. Now on this online editor, you can very easily see that you have something like uh, something like something like left panel, where your contents of code are present, and then you have something like this diagram where you can see the lineage. This is the panel where you can see the code, and this is where you can see the results. So what you would do is, as a developer, what is your responsibility? You want to build a pipeline. As a developer, you should know the basic minimum SQLs. The moment you know the SQLs, what you can simply do is you can create the sequence. Let's say we are building one medallion architecture here. So we would have bronze, silver, and gold. So what I have created is a bronze pipeline where, let's say, I'm reading out the data using a certain command, which I'm going to show. Mm, So let's say the command is like that: create or refresh streaming table. This is a command, something like that. Like this is my table, Brazilian e-commerce personalization, like three level namespace, correct? Catalog, schema, and table. So Brazilian e-commerce personalization and bronze orders. Comment and as select star from, what I would do is I would read from stream. So I have, let's say, already one table. What you can do is you can read it directly from that. You just need to use a keyword called stream so that you can uh, make it as a streaming source. The moment you write this keyword stream, internally it would build a pipeline which is going to take care of, like, first run. From the second run onwards, it is going to automatically consider only the incremental data. So like that, if you write the SQLs, all the bronze SQLs, I have combined it into something called bronze.sql. So I just put everything, and whatever the input tables are there, for now, I have put it a keyword called stream. You can also use something like select star from, select column names from something called read files. So if your data is getting collected into S3 location, or let's say volume, you can do spark.read, you can do the select star from read files. Read file is a new set of function which will help you to read the files incrementally. For now, I have put like stream. So all the bronze tables are written here, all the SQLs are written. The moment all the SQLs are written and I do something called dry run, if I do something called dry run, it will automatically create this pipeline. Similarly, what you can do is you can write silver layer, which is going to be a transformation layer. It is going to read the data from bronze table, and it is going to pass the data into into silver table. So what query you would have on silver is create or refresh streaming table, uh, catalog namespace silver from, select some columns, their transformation from streaming the bronze orders. So what you would do is you would again stream the bronze order and try to read the data, do the transformation, and then pass it into silver layer. So like this it would work. Now what we have to do as a developer is simply write this transformation SQL. After that we go to bronze layer. The moment we go to bronze layer, we would again see the similar set of a pattern where we would have something like create or refresh streaming table, this time the gold table names, their SQL, like transformations, whatever you want to do, and we'll read the data from silver tables. So like this, like create materialize view, MB gold order detail, but this time we'll read it from the silver layer. Once these equals are ready, there is a button called dry run here. I don't know where it is right now because I think my dry run is already done. So the moment I do a dry run, this type of lineage diagram is created. Let me try to maximize and show it to you guys. Like this is an amazing thing. See, so this is a diagram that will be created. This is a complete lineage diagram which tells, like, from where the data is moving, from left to right, how the data is moving. Expand it a bit, yeah, how left to right the data is moving. So this is kind of a streaming table, bronze, streaming table silver, and materialize view customer. The moment we do our first run, automatically the full load is done for the pipeline. And then once the tables are loaded, you can check the data here. Let's start the pipeline, start pipeline compute. In terms of compute, they have something called serverless compute, which is already defined for the pipeline. You can use that, or you can even pass your own compute. That should be fine. You can pass the job compute as well. So like this, the moment the cluster comes up, it is going to run the query, and you can see the data from your table. See, you can see the data from your table. This is a raw table that I have collected from an e-commerce website. Like from it is one of the Kaggle dataset, and I put that as a bronze layer. After that, I can quickly show you how it works for the silver layer. In silver layer also, you can see multiple things, like every table you can go and watch. Otherwise, what you would have to do is always like create table, run a different notebook, maintain it. So this is a much user friendly approach, and you don't need to install anything for this online IDE. The moment you run this, you can see the data. You can watch columns, what all columns are present. You can watch table metrics. If there are any expectation or data quality that is being defined, that also you can see. Since there are no expectation defined for now, we can very easily see the simple table metrics. And after that, you can also see the performance, where you can go a deep dive and see what all things are present as a part of it. So this way, having a left panel where all your assets are present, and then you have a right kind of a display where all the code and everything sequels are present, a browser, an online editor, helping you to simply create a lineage, and then for each of them you can see the uh, right metrics. This is, I think, a very much developer friendly environment that we need for a declarative pipeline. I basically love creating declarative pipeline. What I generally do is I just try to find the data set, or if I have any data set, what I would simply do is I would start putting it into bronze layer and then start writing my transformation for silver and gold. And once the gold data is available, what I do is I simply, but that's a secret, right? So I just simply take that gold data, feed it to Genie, and try to understand it. So this way, just by seeing the data or CSVs, sometimes it is quite confusing how to derive the best result out of it. So this is one of the way I adopt on a Databricks free edition platform. And all these things are completely available as a free on Databricks free edition platform. So this is how I have prepared a nice declarative pipeline, and that can help me to analyze the Brazilian e-commerce dataset. You can do similar for other datasets as well. Going back to the theory, once the things are built up, the most important thing that I would want to show is uh, on Lakeflow declarative pipeline is this. So yeah, let me quickly come down to this benefit summary. What are the benefits of having this declarative pipeline? In terms of SQL and Python, as we know, most of the developers are very well versed with SQL, so they can simply write down SQLs and get the pipeline ready in minutes over the weeks. Otherwise, it would have taken weeks to do that. Okay. Automatic orchestration is already available, so all the basic orchestrations are available. There is a data quality feature which is already built in, similar to Delta Live Table. Observability is there because, as I mentioned, the declarative pipeline, as it runs, it is continuously generating logs in some or the other fashion, right? From data quality run to its own metrics, everything is generated. Now you just have to build out an observability on top of it. Compute, it is all sorted. Serverless is the primary compute. We can use any other thing as well. It is first of all open standard, so hoping that in next 1 year it is going to pick up like anything, and then already Unity catalog integrated. So these are like advantages, features of declarative pipeline. Databricks is promoting it. I have used it. It is amazingly beautiful.